So we're starting lesson 7.5, which is the properties of trapezoids and kites. So the trapezoid. So let's go ahead and make sure that we define the trapezoid. We see it often, and it is definitely different than the parallelogram. A trapezoid, by definition. Now we have started all of these with what especially when we got to rhombus and rectangle, is that those were simultaneously parallelograms. So in the division of quadrilaterals, trapezoid is going to be a non-parallelogram in the world of quadrilaterals. So a trapezoid is a quadrilateral by definition, except for that it has one pair of parallel sides. And the parallel sides are what are called the bases. So up here, I have, and typically people get really obsessed with orientation of these things. They want these bases to be the quote-unquote top and bottom. It doesn't really matter where they are. Like if I change the orientation of the figure, like for example, if I were to draw it like this, right, that's still a trapezoid, right? Just you have your parallel sides that are going to be here. These are the bases. This is a base, and this is a base. What they refer to these other sides are as these guys, which are going to be, that's going to be a leg. Let's rewrite that. Okay. The base angles, okay, so for example, base angles paired here, these guys are going to be base angles. And then in this case, we have these two right here, which they don't have to be congruent, but in this case that they are. Okay. And the reason that that's going to be the case here, I have one more thing that I'm going to note, is if we have this trapezoid here is a special type of trapezoid where we have, of course, we have our parallel bases, but this side and this side, these legs are congruent. This is what's going to be referred to as an isosceles trapezoid, okay, which effectively is just a trapezoid where your legs are congruent. Your bases will not be congruent. Okay, if your bases are congruent, that's a problem because that's no longer a trapezoid. Think about what would happen in that case. If I had bases that are going to be congruent, it means I have exactly one set, right? Let's do that again. Sorry, I got to get the tool turned on doing that. I have one set of parallel and congruent sides that are opposite, and by definition, right, that was one of our theorems for what constitutes a parallelogram. So this guy's a parallelogram. That's not going to be a trapezoid whatsoever. All right? So, I'm going to give you some coordinates. We have A, which is -2, -1. B, which is 0, 3. C, which is 3, 2, and D, which is going to be 4, -3. So let's figure out what this thing is, okay? Now, if it hasn't been told, if we haven't been told that this is a parallelogram, and these are things that are going to be mutually exclusive, you cannot have something be both a parallelogram and a trapezoid simultaneously, okay? So here's our little flow chart. We're going to start with quadrilateral, okay? So we know that, okay? We're going to test if it is a parallelogram, okay? If it is not we're going to have to test if it is a trapezoid. If it is a parallelogram, we have two tests that we have to do, right? We have rectangle and we have rhombus. If it is a yes for both of these, simultaneously, that's going to lead it to be a square. If we have a trapezoid, because it is not a parallelogram, okay? And this is where we're actually going to wind up going this way. No. And because we're going to have a multitude of options. The first one today is going to be, is it a trapezoid? And then we have to figure out if that's a yes or a no, okay? To figure out if it's a parallelogram, we need to test the diagonals, right? So AC, we need to figure out its midpoint, okay? So that's going to be in the midpoint of the other diagonal, which is BD. Now, why do I know that I can just pluck out those 2 points? I haven't graphed a single thing. Well, it's already told me it's a quadrilateral ABCD. If it's ABCD, it means that those vertices are listed in that order, either clockwise or counterclockwise, meaning that I can skip, of course, every other one to determine my diagonal. So it's going to be the sum -2 plus 3, which is going to be 1 over 2, comma, I have -1, right, and 2, which is going to be 1 over 2. That's AC. BD, I have 0 plus 4, which is going to be 2, comma, 3 minus 3 is going to be 0. Gentlemen, this is not a parallelogram. So all this stuff is going to get excluded. Now, we need to check if it's a trapezoid, yes or no. How do we do that? The test, we're going to test the slope of the opposite sides. Okay, so we need to calculate the slope for all 4 sides. Because it is not determined that it would just be A, B, and C, D. It might be B, C, and A, D that are going to be parallel. So A, B, B, C, C, D, and A, D. The slope, right? AB, it's going to be 3 minus 1, right? Over 0 minus 2, which is going to be 4 over 2, which is just 2. The slope of BC is going to be 2 minus 3 over 3 minus 0, which is going to be -1/3. CD, we're going to have -3 minus 2 over 4 minus 3, which is going to be -5 over 1, which is just -5. And of course, now we have AD, which these guys are your opposites. Those are not parallel. So BC is going to have to be the same as AD if this is going to work. Ready? So it's going to be AD -3 minus 1, right? Over 4 minus 2. Oops, I made a mistake here. AB, 3 minus 1 is 4, 0 minus 2. No. Write this down correctly. You have to -1, 0, 3, 3, 2, and 4, -3. So BC. -1/3. Oh, no, I'm doing this right. My bad. This is -2 over +6, which is -1/3. Yeah, of course. Sorry, just double checking myself there. These guys are the same. These are opposite sides. So yes, this is a trapezoid. Now, we need to figure out what type of trapezoid this is. All right? And we need to figure out if it's a yes, is it an isosceles? Okay, now how do we test isosceles? We're going to figure out the distance of the legs. How do I know what my legs are? Well, the legs are the non-bases. The bases are the ones that are parallel, right? So A, B, and C, D are legs. Because they're not parallel. So we're going to test and see what's the distance of AB and CD, okay? So AB. Here we go. Big square root sign, right? It's going to be -2 minus 0 squared plus -1 minus 3 squared, which is going to be -2 squared, and that's 4. And then we have -4 squared, which is 16. So this is going to be rad 20. I don't need to simplify this. You're going to see why, because I'm just going to check if these guys match. CD, okay? And of course, this is going to, rad 20 is going to be 2 rad 5, but I'm not really that concerned about that right now. I'm going to have 4 minus 3 squared plus -3 minus 2 squared, which is going to be rad 1. I'm sorry, rad 1 squared, which is 1. -5, right? 3 minus 3, -3 minus 2 is -5. Squared is going to be 25, and that's going to be rad 26. So this guy is not. It's a no on the isosceles. So this is just a regular run-of-the-mill trapezoid. You can graph a single thing. I wouldn't need to. In an isosceles trapezoid, few characteristics. 1, the base angles pairs of base angles will be congruent. Okay? You also have the diagonals will be congruent. So this is what we have here. Let me go ahead and draw this guy out for us. So here's our isosceles trapezoid. It means this. So I'm going to have these guys be parallel, right? If that's the case, it means that, of course, these guys are congruent. But here's what it also means. It means that this and this, all right, those two diagonals are congruent. Moreover, what it means is that if this angle and this angle are congruent, right, all I need actually is congruence of base angles and opposite sides being parallel, and I have an isosceles trapezoid. And then these two angles would also have to be congruent in that scenario. Just a characteristic. All right, so use it to solve a problem. Okay, let's go ahead and draw one of these isosceles trapezoids out. All I'm given is that this is an isosceles trapezoid, ABCD. Last piece of information is that this is 42 degrees. Okay, so here's our given. ABCD is an isosceles trapezoid. And the measure of angle A is 42 degrees. We're going to find the measures of angles B, C, and D. Now, oops, I'm sorry guys, we gotta relabel this guy. This guy should be, they gave us A, right? So that one's 42. So this is B, C, D. My apologies. Give you a moment to erase that and rewrite that. I think the easiest one to figure out, of course, so looking at the diagram, these guys have to be congruent. So we have to know that the measure of angle D is going to be 42 degrees, okay? That should be straightforward. Now, think about what we have here. I have parallels cut by a transversal, meaning that angle B right there is going to be a supplement, okay? It has to be. It's going to be a supplement to angle A, because AB is going to be that transversal. So we're going to take the difference, 180 minus 42, okay? and that's going to be 138. So the measure of angle B is going to be equal to 138 because of that supplement, all right? Now, because that's the case, think about this. Since I have one set, these both have to be congruent, right? I have one set of base angles congruent. Both sets are going to be congruent. So C is also going to be 138, okay? So there we go. All right. Let's talk about trapezoids having a midsegment. So, still a trapezoid, okay? What a trapezoid will have sometimes is the following. It will have a line that is also going to be going through it, which is, this guy is called the midsegment, okay? Here's what the midsegment does. First of all, these legs are going to be cut into two different congruent parts. Obviously, those segments are not congruent. Moreover, that midsegment, right, is going to be parallel to those other sides. It's just the characteristic of that midsegment. So here we go. We have A, B, C, and D, with the midsegment being named MN. So all the characteristics that we have. If this is a parallel a trapezoid, we know that AB, of course, is going to be parallel to CD. It's also going to be parallel to MN. Moreover, BN is going to be congruent to NC, and AM is going to be congruent to MD. It's just what's done. Also, in this case, when we have a midsegment, what it means is it's going to be the average of the two other bases. In other words, MN as the midsegment is going to be equal to 1/2 the sum of AB plus CD. Okay? Sometimes people overcalculate this. I think it's just one of those things that it's going to be the median of the two. I'm going to give you guys a quick example here, and I don't want you to overthink this bad boy, but again, I'm going to have let's use totally different letters, X, Y, W, X, Y, Z, and then I have this right here, which is J, K, okay? And what we're going to establish is that JK is the midsegment. Of trapezoid WXYZ. Okay? Now, this is all I'm going to tell you guys. If this guy's 10 and this guy's 20, JK, of course we can say that, oh, let's go ahead and go, it's going to be 1/2 of 10 plus 20, which is going to be 1/2 of 30, which is going to be 15, okay? You can, of course, do that. But gentlemen, what number's exactly between 10 and 20, okay? Let's do another example. Same deal. If I make this 2 and this 4, JK automatically has to be 3. All right? I could do it the other way too. Like, let's say that I have 22, okay? And then this guy is 15. We could figure out XY, which would be 8. How did you do that, Granados? Well, again, take a look. This guy's going to be +7, +7, right? It's halfway in between the two of those, okay? Very straightforward. And of course, you can use your equation to solve these as well. I'm not constrained by that. And here's another one. Like, let's say I have 9 and 12. WZ would have to be 15. okay? All right, moving on. Last thing that we're going to discuss today is the quadrilateral that is the kite. Never say diamond to me. We've talked about this before. A kite is a quadrilateral that has two pairs of consecutive congruent sides. But opposite sides are not congruent. Looks like this. I hate when they do that. Okay, I gotta get rid of the autocorrect tool there. Otherwise it's never gonna let me actually draw the figure properly. It means that I have this guy right here, right? I have consecutive sides. They're going to have one pair, right? Like this pair, or I've got this pair that are going to be congruent. But then if I take my opposites, these guys obviously are not congruent. That's a kite. That's it. Last thing, we're going to have two more. Oops, goodness, jumped off the page there. We're going to have two more features here that we're going to denote. One is that your diagonals are congruent. Excuse me, diagonals are congruent. Diagonals are perpendicular. Should have said that. And then also, we have exactly one set of one set of opposite angles are congruent. All right? And it's always this one. It's always the one that's going to be the joint of the two consecutive non-congruent sides. So right here where these guys, oh goodness. Where these guys are congruent, right? This guy, that guy's not going to be congruent, okay? That's just not the case. If it is, it's not a kite anymore, all right? So it's always going to be this guy. All right. Let's have some fun here. Let's make a kite. It's like the world's worst kite. That thing would never fly. Funny thing is, the popular kite that you guys see is typically a triangle. Okay? Aerodynamically a little bit more simpler. This is going to be A, B, C, D. This is your kite, okay? This guy is 80. This guy is 50. And we're going to find the measure of angle C. Okay. Well, we know the following. The measure of angle C is going to be congruent to the measure of angle A, right? So we don't know that guy. It's just going to be x. So in other words, x plus 80 plus 50 all have to have the sum of, remember, it's a quadrilateral, all have the sum of 360. So in other words, I have 2x plus 130 is going to be 360. Subtract 130 from both sides. Please use your calculator. Oh, probably don't even have it out. Classic. Only been begging you all year long, but you know, you're on your own. Good luck. X is going to be, when you divide both sides by 2, 115. All right. And that's all I've got for you for today. So I'm going to go ahead and let you get started with your assignment. Good luck.